Hello, good afternoon. Hello, hello, hello. Is there anybody out there, as the song goes? Is there anybody there? I have some kind of activity that I might do today. Although, of course, if you have questions, I'm happy to answer your questions. Because there's a notebook in the office hour folder which I uploaded half an hour ago, 40 minutes ago, called MoMA, MoMA .ipynb, which has a bit of code to download some data and then some questions to answer using that data. It's similar in nature to a mini project, although there's no grades, there's no grader. But, it's the kind of thing that we may want to do when I have some data of some interest. So, hello, Ines. How are you today? As I was saying, I have some activity that we might do today, unless you all have questions for me, because I'm, of course, happy to answer questions. Let's go to my server, data course, MoMA. I wanted to use the data from the fire department of New York, but I would need to filter it first because it's too big to load on this Jupyter Hub. So I went for a data set about works in the Museum of Modern Art, which is a museum in New York City whose website was down a moment ago. Oops, the website's back. This is the Museum of Modern Art in New York City. There are two locations, one in Manhattan and one in Queens. I've been to the Museum of Modern Art many years ago. And, right, the Museum of Modern Art has some data set available online. I mean, I've downloaded a copy of one of their data sets at a particular time. I'm trying to remember, it might have been here in the archives. I can't remember exactly where this data set was located at the moment. Oops, they're still having difficulties with their web server, it looks like. So, exhibition history list. Anyhow, as I was saying, if you have questions, feel free to ask your questions, whatever they may be. If you don't have questions, I was going to work on some other questions with regards to the Museum of Modern Art information. If you look in the office hour and supplemental notebooks, which is this file here, you'll find this MoMA.ipynb notebook, which you could download and follow along with. That's this notebook here. This first cell will retrieve the data, but I have already retrieved this CSV file, so I'm not getting it again. But if you were to run this on your Jupyter Pod, it will download your data, download some data here. So again, shared folder, office hour, and supplemental notebooks. So it's in that folder, and it's the MoMA.I, so MoMA.ipynb in that folder. It's this file here, which you would have to download and either run on your own local machine, or you're going to have to upload it onto your Jupyter Pod to run this notebook. And again, this first command will download a CSV file with information about exhibits in the Museum of Modern Art. I'm going to import NumPy and import pandas. I'm going to read this data frame. And then I had some questions here to answer. This is what our data frame looks like. So there are, how many rows in here? There are 138,151 rows in this data frame. Each one of these is referring to some piece of artwork that is owned, possibly, or maybe they have information that about exhibits they have on loan as well. These are, but I think these are all owned by the Museum of Modern Art. So we have things like, the title of a work, an artist, something a little bit about the biography of the artist, nationality. I don't know what the begin and end dates refer to. I would need to, here's another link. Hang on, let me provide another link. So what's here is a link with some information. So as I say, this is a research data set. Pull requests do not represent. Anyhow, so yeah. Gender of artist, date of when the particular work was made, I believe, medium, etc. with duration, like there's some, a lot of these data, how do we use the materials downloaded from this course on GitHub? I'm not sure what you mean. I mean, we ask that you don't upload this material on GitHub because it's copyrighted material, right? Our notebooks are copyrighted material. So we ask that you don't upload our notebooks onto GitHub. But I'm not sure I understand your question. So some of the material in these artworks are like film or sound, I think. And so they have a duration of this film or sound, which is not applicable if you have an ink and cut and pasted painted pages on paper material. If I could spell tonight. Right, you can see these are the columns in our data frame. So again, title, artist, constituent, artist bio, nationality, medium, dimensions, a session number. I don't know how this is, what this means, classification, department. There are different departments in the museum. Date acquired, and so on. So there's some questions here, to attempt to answer using this material in this data frame. And once again, if you joined a bit late, there is a notebook available. So control panel, video downloads, and office hour and supplemental notebooks. Office hour supplemental notebooks, you go in there and there is this notebook called MoMA.IPYNB for Museum of Modern Art. This is the notebook that I'm looking at. Right here. So again, the first line, we'll download the CSV file, we'll import NumPy and Pandas, we'll read the CSV file. This is what our data frame looks like. There's 138,000 rows in this data frame. We want to aggregate some information about this data set. So we have a couple of questions here. There's no grader to run here. There's nothing of this form. We're just looking to examine a bit of information, find some information. So here we're saying load the data, remove all rows that are missing a value for any of the following columns. Well, we've loaded the data. We want to remove all rows that are missing a value of any of the following columns, i.e. title, artist, or date acquired. Well, this is where we use the drop method, or drop NA method in Pandas. Right, so I could say drop NA. The method where any of these elements are missing. We don't want to look at all the columns. We only want to look at some columns, and we specify this using this subset argument. So if they're missing a title or an artist or a date acquired, this is, so if they're missing any of these three information, then we want to drop that row. And this will give me a new data frame, and I'm going to save that to the same name. I'm going to say df equals df.dropNA. How many rows remain after dropping? So we started with 138,151 rows. After dropping anything that is missing a title, artist, or date acquired, we're left with 129,930. So what, that was not quite 9,000 rows that we dropped. Of the pieces listed, of all the pieces listed, what proportion belong to the photography department? Well, department. Well, I said there's different departments in the museum. Oh boy. Right, there's an architecture and design department and drawings and prints and so on. So what, there's 2, 3, 4, 5, 6, 7 departments. We're interested in what proportion belong to the photography department. So anybody want to give me an idea of how I might answer this question using our nice tools from Pandas to do this? What proportion belong to the photography department? There are many ways that I can answer this question. Some may be easier than others. Any suggestions? Apologies, I should have left my phone outside. Just been dealing with some personal things today. Any suggestions? Remember, like, Pandas has lots of ways of filtering data. If I select the department column and compare this to photography, this gives me a value of true or false for each row. Count of photography department divided by total departments. Yeah. So there's, right, I could say df department equals photography, like I did before, and I could filter to keep, only those rows. If I did a length, this will give me the number of items for the photography department. I could divide by the length of the whole data frame. What I could do is, as I said, there are many ways we might do this kind of thing. Again, this right here gives me a true or false. I could take this series and compute the mean of this series. When pandas computes a mean, it will interpret false as 0 and true as 1. Right, so a true or false series, again, pandas will interpret false as 0 and true as 1. There's another suggestion. I could say df department value counts. Right, this would give me the value counts. I could select photography, and then of course I could divide by the length of the data frame to get, you know, that percentage as well. Right, so, you know, like many things in pandas, more than one way of getting an answer. You know, I kind of like this method because, well, right, I don't have to I mean, yeah, I could just do value counts divided by the length, and this will give me the fraction for all departments, right? But if I wanted photography in particular, I could select. Right, if I wanted photography in particular, I could index into this. If I put some parentheses appropriately, I could index into this data, into this resulting data frame. All right, remember this gives me a whole data frame, or sorry, a whole series in this case. All right, where the index in the series is either drawing and prints, or photography, or Fluxus collection. All right, so I could supply an index into this series and get the fraction I want. So, you know, again, any of these methods will, you know, give you the, you know, if I wanted drawings and prints, then, you know, I could get the fraction. I need to put some parentheses around this entire expression. Otherwise, pandas seems to be trying to apply the index to the length right here. So yeah, that's, yeah, as I said, keep in mind that in a numeric context, pandas will treat false as 0 and true as 1. And so, you know, this can often be a shortcut. So any other questions or comments? Right, so yeah, what proportion belongs to the photography department? So nearly 24%, 23.909%. So nearly 24% belong to the photography department. Whereas, for example, the drawings and prints, well, is nearly 57%. Again, this right here will give us the value for every department. Looking at the title for each work of art, how many unique titles contain the string untitled? Where I want to, not care about the case. So df title gives me, the collection of titles of the works. How many unique titles contain the string untitled? Here we could use some string methods that are built into pandas. Right? So this right here gives us this series. I can access the string methods with the .str method, right? This basically gives me the collection of string methods. If I if I use the .lower method, this will lowercase all of the titles, give me a new series. Well, I can access the string library again, and I could say, well, untitled, right? Again, so the string method has a contains method. Oops, untitled. And again, this could give me, a true-false value, is in method. We could talk about that here, df. Right, again, this will give me the collection of works. Right, so this first portion gives me the collection of works. Again, I will select the title column because that's what I want, and I want how many unique titles contain the string untitled. Well, here we could use the nUnique method. Right, remember, this will give me the collection of titles. There's 18,385 items that contain the string untitled. And I want the number of unique items. And I could call the nUnique method in pandas. There's a suggestion. You could say df title str lower str str is is in. Or what do you mean by the is in method? I want the title to be is untitled to be in the title. I mean, how do we use the is in method right here? I'm not sure that I am following. Right, I want untitled to be in the string, not the title to be contained in something else, if you see what I mean. So having thought about the is-in method, I'm not certain how I would use it in this case. Because, you know, there's, yeah. So I'm not certain I have another good way, you know, without starting to write my own functions and use the apply method. Right, like I could write a function that would say take a string as input and say is this string a substring of that one, and then use the apply method on a series, but df title apply lambda x untitled in x dot lower. And then I could select the rows again, and then I could select the title and then go in unique. So right, I could use the apply method like here. To again give me a Boolean series, right? I write some function that would work on one string. So x right here is one of the titles, and I want to say is the string untitled in this lowercase version. David, the lowercase u stands for Unicode, which is a little probably unnecessary because Python 3 strings are Unicode by default. But so maybe a little bit of a holdover, or you know, from previous versions of Python. So U stands for Unicode. Any questions about how I got this answer to this untitled titles? I think a lot of them are probably like untitled, you know, untitled by some artist. You know, you have things like untitled by Bob Dylan. You know, untitled something rather, untitled by this artist, etc. So anyhow, so question about the medium and the materials, you know, of the works. So there's a claim. I'm not, you know, looking necessarily. It says MoMA tends to lean more heavily towards printed works rather than painted works. So again, if we look at the, I mean, we saw the value counts before. So df department dot value counts. And I said printed works rather than painted works. So drawings and prints, photography, right? Painting and sculpture, you know, is much less than like print and photography and so on. So what about the materials on which these prints and paintings appear? Looking at the medium for each work of art. The medium is one of the columns, DF medium. Right, this is one of the columns. Looking at the medium for each work of art, report the ratio of the number of works that contain the string paper compared to those that contain the string canvas. I think this here says note, case sensitive. This should be not case sensitive. So looking at the medium for each work of art, that's all works of art. Report the ratio of the number of works that contain the string paper compared to those that contain the string canvas. Well, we've seen, you know, right, how we could do the kind of string containment question. We could say medium string dot lower dot str dot contains. So I want paper. Right, again, this will be true, false. Now, remember what we just talked about a bit earlier. Falses can be treated as ones and trues can be treated as zeros. So if I did a sum, then I have the number of works whose medium contains the word paper. Right, and I could divide this by the number that contains whose medium contains the word string. And I do a sum. Contains, dot to sum. Was it string, paper, oh, canvas, sorry, contains canvas. All right, so, you know, again, df medium.str.lower gives me a lowercase. .str.contains paper will give me a true or false value for each work of art. And then doing the dot sum in the end will again treat false as 0 and true as 1. And so I would get the number of works whose medium contains the string paper. I could do a similar thing for, you know, which works of art medium has the string canvas, and then divide, because I want the ratio of the number of works that contain the string paper to those that contain the string canvas. So there's about 9.2 times, you know, as many, you know, for every work of art that contains the word canvas, there's about 9.2 works of art that whose medium contains the word paper. mean, why would we be interested in this? Well, I don't know. Maybe if I was a manager, one of the people who works in the archives, some sort, maybe in terms of preservation, maybe paper or canvas, right? There's cost associated with doing preservation work or touch-up work or storage cost or something. So, otherwise this may be, just a, what can I say about this data set? So I don't know that this is interesting on its own, but so remember before I said some of these exhibits, these works of art, whatever you want to refer to them, are actually like film or audio, or video, right? So they have a duration. So the works with a non-null positive value for duration, i.e. column duration seconds. So again, df.head, or let's go tail, just for something a bit different. Right, medium, so these are books and or films, or sorry, these are works of art. So duration seconds, well, we want non-null values. What proportion of these durations are listed as being longer than 10 hours? So I need two things. One, I need values that I need works of art that have a positive duration. But again, that's easy to do. All right, df duration, as long as I get the name of the column correct. Duration space parentheses sec period. All right, this gives me this series. I say the ones which are positive df, and again I could do a selection right here, and this will give me these values, and I could select duration, select the duration column again to just get duration. Oops, sorry. I could do, I could either do a loc or I could do a right. So I select the ones whose duration is positive. This will automatically throw away all the NaN values as well. I want the durations and, well, right, I could basically, filter again. Right, so let's take the duration. Durations is this variable. Right, this is all of the works that have a duration value which is positive. Now, these durations are measured in seconds. What proportion of these durations are listed as being longer than 10 hours? So I want durations which are greater than, what, 10 hours. 10 hours, there's 60 minutes in an hour and 60 seconds in a minute. Again, this will give me a series of true-false values out of these ones that have a positive duration. So once again, I could take a mean of this series, and this will give me the the proportion, right? Remember, this will give me a true false, and the mean will interpret false as 0 and true as 1. So a bit more than 1% have a duration longer than 10 values. I might want to know this. I might want to know durations greater than 10 times 60 times 60. DF unalignable index. Oh, I see. Right. Yeah. All right. And yes, as I said, DF duration, because I don't have a true-false value for every duration. The way things go, Berlin, Alexanderplatz, escape mates, Ohio. Herb Schiller reads the New York Times. Wow. History and memory. I like America. America likes me. Turgescent sex. Okay. Free, white, and 21. Anyhow. Only 24 rows. So, anyhow, we filter to keep the ones that have a positive duration, and then we can kind of do another filter and compute a mean. So again, this is 1.3% of those that have a positive duration. Question 6 we might skip because we've not actually talked about, this is where I might use some scikit-learn. This might be something to, where I'd use scikit-learn. We have to do a bit of grouping and conversion. And we might come back to that at the end if we have some time. Aspect ratio. How many of you have heard of the golden ratio? It's supposed to be, saying something about, what's kind of beautiful. Two quantities are in golden ratio if the ratio is the same as the ratio of their sum to the sum, but this is more about the aesthetics of columns in architecture, especially in Greece. And this shows up a lot in nature. So-called golden rectangle, and you start with a rectangle. So I have a square of side length A. I add on a rectangle whose one side is length B, so the other is A plus B. And the idea is, well, if you start drawing some kind of spiral and you repeat this sort of process, thought I would have had a nicer picture. Oh, this is the kind of thing. Or if you do this kind of spiral and you repeat by dividing, you know, these things into smaller areas, you'll get the so-called golden spiral. But yeah, so I mean, won't go into. So what we want to do is we all the works in the department of drawings and prints whose width and column are greater than 0. Compute each aspect ratio as the width over the height. It says what proportion of these aspect ratios are within 1% of the golden ratio. So we're going to take the golden ratio to be 1.618. So what we want to do is we want the works in the Department of Drawings and Painting. So let's do DF, D and P is DF of the department is equal to drawings and prints. So we'll select all of the works of art for the Department of Drawings and Prints in this new data frame. And we might do a bit more filtering. I want and DF of the width in centimeters is positive. Let's put some parentheses around this here and all these things so that pandas won't complain. Right, I want the department to be the drawings and prints, and I want the width to be positive, and I want the height in centimeters to be positive. So we keep all of the ones in drawings and prints that have a positive width and height. And then what we're going to do is we're going to slice in a column. D and P is equal to DF, D and P, DF, P ratio, let's say aspect ratio. I take the width and I divide by D and P, I divide by the height in centimeters. DFP and D and P, if I can get it in the right. So the tail. Do I have an aspect ratio out here as a new column. So I have an aspect ratio. I want what proportion are within 1% of the golden ratio or the inverse of the golden ratio. So this is when I want to use the apply method again. Either I write an external function and apply it, or maybe I could, you know, I could say df d and p aspect ratio lambda x. So x is an aspect ratio. Whose aspect ratios are within 1%. So it could be 1%, you know, of the, let's see here. So I want to look at the difference. So x minus phi divided by phi is less than, let's say, less than or equal to 0.01. What proportion are within 1%? So basically, you know, we could go above or below. So I want this to be true, or I want x minus 1 over 1.618 divided by 1.618 to be less than or equal to 0.1. Right, so I want the ratio of the width over the height. And I want to look at the difference. So I take the difference in the golden ratio divided by the golden ratio, or the ratio and the inverse. Oops, this should be 1 over 6.8. And again, this will give me a true or false. And what can I do with trues and falses? I could take a mean. I could get a mean to figure out. That seems rather large. I'll have to double check what I'm doing this correctly here. Oh, I want absolute values. Absolutes. Oops. Put my absolutes in the correct location. Again, I need to double check. I have to check my calculations here that I'm doing this. That still seems higher than I remember. Less than or equal to. Anyhow, we could pick this up tomorrow, or indeed, I might talk a little bit about some web scraping tomorrow, or using APIs tomorrow, or something else which is of interest. right? It's largely, well, you guys didn't seem to want to suggest something to me for this week, so I, went out and found this data on my own. So using APIs. All right, we could probably talk about that tomorrow then. I will wish you all a pleasant weekend, and I will see you tomorrow.